Hello. Oh yeah, it's there.
Good.
Good afternoon, everyone. Hope you had nice lunch and not sleepy. And I'm gonna show up really nice things here on the immersion cooling side for SSDs. Myself, Hardeep, and I have my colleague with me, Karissa. We're gonna talk about immersion cooling, how it's gonna play a role with the SSDs, and what's gonna happen in the SSDs area as well. So let's get started there. I think these advantages and challenges are well known. I'm not going to repeat. Immersion cooling is now, OCP has started the working group, but yeah, there is advantage of thermal, there is an advantage of lower PUE, smaller carbon print, and then you can get the better reliability also. But the challenge again, the main is the material compatibility. What is the validation? What is the validation and test criteria? So someone can say, hey, I approve this SSD for next 5 years, 10 years, whatever that number of year is. I validate it, and you can take it and put it inside the immersion cooling environment. The plot there we have, it's showing how SSD power has been growing in the past. If you see PCI Gen 3, Gen 4, even Gen 5, they are all up to 25 watts. Yeah, air cooling is good, can do that. But what I'm going to show you a plot in the coming slides, the Gen 6 and Gen 7, they're going higher and higher power. If you want to take full advantage of the performance from SSD, you probably have to run it higher power. And there is not one single SSD in the server. It's not like GPU and CPU. There are bank of SSDs inside the server, and they all need to be cooled. Even though, let's say, one SSD is of, I'm just going to pick up a number, 50 watts, and you have 24 of them or 25 of them in there, that's totally going to be 2,500 wattage of power there. What do you do there? Would you attach a liquid cooling cold plate there for each of them with so much copper, or you dump it inside an immersion cool environment, and you don't need to put probably any thermal solution, not even a heat spreader for the 50-watt device. So going to the next one, this is where we are comparing SSD thermal performance in air-cooled environment and an immersion-cooled environment. If you see 25 watts, yes, there is a margin in air-cooled environment. You have a 25 watts drive. In a typical data center with 35 degrees Celsius and with a typical fan flow, no need to run the fans at higher speed, you can cool 25 watts power on SSD. Immersion, this immersion data is based upon simulation, and one of the worst form factors, it has a lot of margin. We go next generation, let's say 30 watts in Gen 6. You still have a margin on immersion, a lot of that, but air cooling is hitting its limit. And Gen 6 is coming way faster than what we expected. It's not, Gen 6 is not now, they're already, you must have seen the demonstration, Gen 6 drives are there, they're talking about the speed there. So Gen 6 is just 1 year, 2 years from now. What's going to happen after that if somebody wants to take an advantage? Air cooling is already out of gas. It cannot go beyond 30 watts, and that's where the Gen 7 comes. So other than other advantages of immersion, SSD is also hitting the thermal bottleneck where we need to do something different than air cooling. SSDs were initially more with the, hey, we are just following up the industry trend. We are going with the CPU and GPU because they are dumping the entire server. Story is a little different now. We are starting thinking, hey, what are we going to do? We cannot cool the drives in air cooling. With that, I'm going to hand it to my colleague, Karissa here. She's going to share with you about the validation and what we have come up with for SSDs, and we're going to pursue there. Here you go, Karissa.
That's right. So when Hardeep tells me we need to start dunking these SSDs in an immersion cooling fluid, as a thermomechanical reliability engineer, I was like, what? Okay. So really leveraging the awesome framework that has been demonstrated at the OCP, this is our qualification methodology, and I will go through the qualification strategy that we are planning. So really, the very first thing you want to do is establish your baseline, and I've heard this a couple of times today, so I think this is the great work from OCP to establish that framework. But you establish the baseline in your air cooling environment for the thermal and the power and the performance. You're looking at SSD functionality. The weight and dimensions is important because you want to know after you've submerged in the immersion fluid, the difference, right? What is the material properties of your components? and how they are changing from the immersion fluid. So we've established the baseline, and now we're going to submerge the SSDs into the fluid for the aging. And there's several different accelerations to be used on what is that equivalent server life. And during that time, we're testing the functionality, thermal and power performance, and also what's mentioned many times again today is the fluid compatibility and that fluid functionality. So leveraging, again, the OCP guidelines on all of those things is what we're doing here. And then post-immersion, so you've soaked them, they've aged for several months, days, whatever that service life equation is, and then you're redoing the test, and you're ensuring that the material property of the system has not changed, and by doing thermal mechanical reliability testing for end of life. Teardown is also important. I mean, afterwards, you want to open these up and do cross sections. You're looking at your metallurgy changes. Did the PCBs become more brittle? Is the labels still adhered? So this is our qualification methodology, and then we'll go through some results that we've had. Some of the past criteria that we've been using is mechanical reliability is really following the JEDEC specs, which are very well known. Temp humidity, temp cycle, shock, and that's again just to look at the reliability changes from your baseline now that they've been submerged in these several different fluids. Electrical functionality, we are looking for no data corruption, no functional fails, and we're really following a JEDEC RDT workloads, SSD performance, and weight and dimensions, as I mentioned. So our pass-fail criteria for several of these are what we have currently in air, and also what OCP has been demonstrating. So electrical, and so really we're trying to look at the bathtub curve, right? What is your defect count, your infant mortality, based on the interactions of the materials with the new fluids, and then what is the reliability of that in several different instances. So this is some of our early testing results. First, you do the component. We did many different types of components at the component level and then at the SSD level and different fluids. So we were kind of, one of the challenges of the SSD reliability is which fluid are we going to focus on. So several different types of fluids here, and it's ever changing, and I think that's one of our main challenges is going forward is to certify the certain fluids and the compatibility. There's some of the results here. We're looking at the changes in the dissipation factors and functional fails. So far, we've been largely successful. We have not had any functional fails. Several different components have performed a little bit differently in different fluids, and so we're just working on establishing that baseline and that foundation. This is just a little more details of the different types. So there's lots of different form factors of SSDs and different BOM components, or again, creating that foundation of the different component reliability in the different fluids. Some of those have then gone into thermal mechanical, and we have not found any difference between the pre and post functionality and the mechanical reliability of our SSDs. The teardown, again, is important. We're doing a lot of visual inspections and cross-sections of via reliability and looking at the grain structures and how does the interaction between the fluid and the SSDs perform. One of the observations was that the thermal interface material was actually absorbing some of the fluid. It did not interface or interfere with the functionality of the drive, but you can see there that there was some differences. So. Our SSD qual strategy day, so that was our early testing and kind of a proof of concept. We're looking at tons of different fluids and what should we focus on? What is the main, in collaboration with our suppliers and customers, what is the focus of fluid we should be focused on? And we have a longer term plan to really qualify different fluids selections. And again, the area of investigation is thermal characterization, material compatibility, and then the thermal mechanical reliability. I think that, again, is the framework, and I want to thank the OCP for providing those guidance. One call to action is we are just using our functionality tests that we do in air. So is there certain or different requirements that might be necessary to completely qualify in an immersion environment? So understanding those requirements, what I just heard in the last presentation, right, is what are those, are the requirements different for an immersion environment versus our air environment? We're using our standard RDT, JEDIC workloads, but is there something we're missing? And so we're looking at different validation methods and different workloads to ensure that we're covering what's needed out in the field. So the call to action is to define that test criteria, those workloads, define a standard for SSD particularly, and then the specific test fluids. What fluids are coming, what fluids should we be testing to be prepared for the next, the next collaboration. And with that, we have a cool booth out there showcasing some liquid cooling, so please visit us out there. Was there any questions?
Please, go ahead.
Yeah, hi, I'm Steve Pignato for Standard Fluids. I think you guys did some testing on the two-phase fluids when I was at 3M. Is that data available, or is that something that you would present? And how did it look versus the single phase?
Yeah, we were really focused on single phase here.
So data do exist.
Yeah.
We don't have the data. We are not presenting the data. But I can say at high level, we are not seeing any issues. The way the material in SSDs and the compatibility there is good. But I do, because you asked a question, I'm going to give you a question back. The only challenge with the two-phase, every night, 1-inch two-phase flow keeps going down in our lab. And the guy is sitting in the front of this row, and he's like, Hardeep, please don't bring two-phase.
I can help you.
Okay.
Piece of cake.
Okay.
Thank you. Any other questions? Okay, thank you very much. And